this lesson, we'll be covering some collections and loops. Let's say you go to the grocery store with this shopping list: cereal, milk, and toilet paper. When you walk into the store, the aisles are divided by numbers and have a sign above them with an example list of items you may find in that aisle. For each aisle in the store, you quickly scan each sign to see which aisle has the breakfast or cereal items. Once you're in that aisle, you go through each section and scan the cereals. The bag cereals versus box cereals, chocolate versus fruity, etc. For each cereal that you like, you then add N of them to your cart. You then do the same thing for milk and toilet paper before going to checkout. For each checkout lane, you quickly scan to see which checkouts are available, and you try to find the shortest line. We could go on, but the point is, every time there was a grouping or list of things, like cereals, that was a collection. Every time we said for each, we were iterating or looping through a list of things. One type of collection is called a list. This is a super common data type since we deal with lists of things all the time. To make a list in Python, all you need are square brackets. So anytime you see square brackets, you are most likely dealing with a list. Let's go through some examples so we can see what lists look like and what you can do with them. Feel free to pause the video and try out these examples in the Python console. You can initialize a variable with an empty list by either assigning it an empty list with square brackets or using the built-in list function. The list function is preferred, but both will work. You can then add items to the list later on. You can also assign variables with lists that are not empty. Here is an example of a list with integers and a list with strings. You can grab a single item from a list by indexing into it. This is where we use the position of the item to pull it out. The first item in the list is at position 0. This is very important to remember. Just take a look at these outputs here. Numbers index 0 returns the first item 1. Numbers index 1 returns the second item in the list, which is 2. Numbers index 2 gives us 3, and numbers index 3 raises an index out of range error because there is not a fourth item in the list. Pop returns the last item of the list and removes it. So if we have numbers of a list of 1, 2, 3, and then pop the last value into our variable x, then when we print x, we get the output of 3. Also notice how the output for numbers is just an index of 1, 2. We removed the last item. Append adds an item to the end of the list. So here's our numbers list of 1, 2, 3. When we append the number 4, now you can see that our numbers list now has 4 elements in it: 1, 2, 3, and 4. Remove removes an item that is in the list. Numbers again, 1, 2, 3. If we remove 1, then you can see that our numbers variable is now just a list of 2 and 3. If we try to remove 5, it would raise an error because 5 is not in the list of 2 and 3. Reverse reverses the items in the list. 1, 2, 3 dot reverse would now give us the output of 3, 2, 1. Sort will sort the items in the list. So given this unordered list, 2, 1, 7, 5, 9, 3, once we sort it, the output is now 1, 2, 3, 5, 7, 9. There are more built-in functions for lists, but some of the functions we went over even have parameters so you can change their behavior. For example, Sort can be set to sort by ascending or descending order. For now, we'll leave it here and move on to loops. The two loops we'll discuss in this lesson are the for and while loops. First up is the while loop. This is a more uncommon loop, but you use this loop when you need to perform some operations until a condition is met. In other words, any code within the while block will be run over and over again until the condition is met. In this example, we have the while loop on the left-hand side and the output it generates on the right. This example would read, while x is less than 5, print x. Then add 1 to x and try again. These are the steps that the example would take. We start with x equals 0. Then start the while loop with the condition while x is less than 5. We then create the while block, and the first line in it is print x. The first time this goes through, print x would be 0. Then add 1 to x, and since there's nothing else after that, we go back to x is less than 5 and check the condition. If the condition is met, break out of the loop. Else, go into the loop again. X is now 1, which is still less than 5, so back into the loop we go, and repeat these steps until x is no longer less than 5. So, in the output on the right, you can see that we go through this loop 5 times. The first time, x is 0. The second time, x is 1, then x is 2, then x is 3, and x is 4. Once x becomes 5 and it checks the condition, 5 is less than 5, that's false, and so it breaks out of the loop. Let's look at one more example with more complicated logic. While today is not the weekend, I'll wake up, go to school, do my homework and eat, and then go to sleep. And then the next day will come. Eventually, today will become the weekend, either Friday, Saturday, or Sunday, and we'll break out of the loop. Notice how eventually the while loop's condition is met. You need to do this or else you will never escape the loop. Never breaking out of it is called an infinite loop, and that either causes crashes to your machine, it raises errors, or causes memory leaks. Basically all things bad. If you had a loop that looked like this, then this loop will never stop doing something. You need to break out of the loop somehow. So, you can either set a condition that is eventually met, or you can use the break keyword. The break keyword is specifically designed to break you out of loops. Whether they're while or fors, doesn't matter. It will always break you out of the loop. Oh, and by the way, if you are in a function, you can use the return keyword, which will return the value and break the loop. The while loop needed a condition. A for loop needs a collection to iterate through, like a list. Code within the for block will be run for each item in the collection. Let's just take a look at some examples. Just like how the while loop started with the while keyword, for loops start with the for keyword. Then we give the variable a name. I called it num, and that will represent the current item in the collection as we loop through it. In plain English, this would read, for each num in the numbers list, print the num times 2. The first time the loop goes through, num would be the first item in the list, which is 1. Then it would print 1 times 2. Then it goes back to the for statement, and num is now assigned the second item, which is 2, and prints 2 times 2. Then it goes back to the top, and num is now 3, which would print 3 times 2. And then it would go to the top one last time and see that there are no more items in the numbers list, so it would break out of the loop. Here's another example using the days of the week again. For every day in the week, print that day. And that's why on the right you see the output of Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday. And that's really all there is to a for loop. Just give it a collection you want to iterate through, and bippity bop, you got a for loop going. Let's talk about strings for a minute. If you think about it, a string is just a collection of characters. This means that you can kind of treat them like lists. Now, strings don't have methods like .append or .pop, but you can iterate over strings. I'll show you what I mean. In this example, we'll loop through my name and print out the uppercase version of it. For every character in Carlos, print that character, but capitalized. On the right-hand side, you see the output of capital CARLOS. If you did need the string to be in list form, you could do that with a built-in list function. This function will take anything and try to turn it into a list. Just look at what happens to my name when I put it through that list function. My name of Carlos in a single string gets turned into a list of CARLOS. On the inverse of that, you could turn a list of strings into a single string using the built-in join function. This time, we start with name as list with CARLOS, and then we join all of the characters in that list to then create my name in a single string, Carlos. See? Aren't lists and strings super cool? They are both powerful data types and super common in the programming world. Make sure you practice with them. The last thing we'll talk about before giving you a challenge is the in operator. You've now seen it in a for loop, which is used to iterate through each item in a collection. But you can also use the in operator to check if an item is in a collection as well. Let's say I wanted to search for a book at a bookstore. I would go to their website and perform a search against their inventory or collection of books. Let's see what this looks like in code. We'll start with the book I'm searching for. I'm searching for Ender's Game, which is one of my favorite books. We can then see what they have in their inventory. They have the Clean Code book, Deep Learning with Python, and Naruto Volume 1. Visually and manually, we can see that Ender's Game is not in their inventory, but how will we check that programmatically? That's what this if object in collection is for. So let's look at the if statement. If search is in inventory, print add book to cart. Else, print the book is not available. And in our case, because Ender's Game is not in the inventory, we're going to see the message displayed, book is not available. You may have picked up on this, but search in inventory was a Boolean expression. This means that we can even use the in keyword in our assertions. Instead of just using an if-else to check that Ender's Game is in the inventory, we can actually turn this into a test and assert that search is in inventory. Okay, I think you have all the tools you need to complete the next challenge. In this challenge, you need to create a program that does the following. Takes any sentence or word as an input. Then counts the number of vowels in the input, and prints that number back to the user. As always, start with your tests, whether in BDD or TDD form, and think of different inputs the user could give you. And don't forget to create the Chapter 4 branch, and also the Chapter 4 folder under the chapters package. The rest is up to you. So design and architect this in whatever way you want, but pause the video until you're complete. Next up, I'll show you challenge 2. Alright, we're back, and now we're ready for challenge 2. This is the challenge that will end this lesson. Create a program that does the following. Takes any word as an input, and checks if the word is a palindrome, and then tell the user whether it is a palindrome or not. If you're not sure what a palindrome is, then you better get researching so you can complete the challenge correctly. Add this challenge to your Chapter 4 folder, and then complete it however you'd like. This lesson is over once you submit this, get it code reviewed, and then your branch approved and merged. Let's see what you got. Once you're done with challenge 2, we'll move on to dictionaries.